My name is Yanofsky. This is the Outer Limits of Reasoning. This is CIS 1002. And today we're going to do Chapter 3, Philosophical Conundrums. Okay. First, this class really should not be done on the internet, should not be taped. It has to be done in front of people because the first part of the talk is basically a lot of question and answers, okay? And so usually I have the interaction with the students to interact. So I'm doing this on tape because I wanted to do the entire class on tape, but this particular class, this first section, really should be done in person. And you'll see what usually takes like 2 or 3 hours, 2 or 3 classes to talk about will be done a lot quicker because I have no one to talk to. So it's going to be like that. Okay, great. So we're talking about philosophical conundrums. Conundrums are problems that philosophers talk about. So this class is about the limits of knowledge, what people can and cannot know. These questions have been dealt with by philosophers for thousands of years. They've been talking about this for thousands of years. So it would pay to look in to see what they have to say, and I'd like to do that. Okay. So we start off and we talk about a problem called the Ship of Theseus. Okay, let's talk about this. Okay. Theseus was a general. He was a general in ancient Greece. Okay, Greece used to be made up of a lot of little city-states by themselves, each one separated, and he was a general, and he went going around all these different city-states, and he fought with them, and he kind of combined them to make one big country called, I don't know what you call it, maybe Athena or something like that, but they were all unified after Theseus. And when Theseus died, they wanted to make a memorial for him, and what they did was they took his ship that he had traveled around, and they put it in the port of Athens, and they said, this is Theseus' ship. And people on Sunday afternoons, they would push the strollers and take the kids to see Theseus' ship. Okay? We do that ourselves. We take old warships and we make museums out of it. Okay? On 11th Avenue in New York, you have the USS Intrepid. Okay? They took a World War II ship and they made it into a nice museum, and kids go visit, etc., etc. The South Street Seaport is an old wooden boat, and they made it into a museum. That's on the east side of Manhattan. And if you've ever been to Boston, the USS Constitution is a Revolutionary War ship. Okay, it's a wooden ship, a Revolutionary War ship that you can visit, and it's very nice and it's very interesting to see. So this concept is not a new concept. Okay, great. The ship, Theseus' ship, was in the water for hundreds of years. Okay, it's in the salt water of the Mediterranean for hundreds of years. Okay, and the planks of the ship started rotting away. Okay, now they want to keep this museum. They want this museum to running well. So every once in a while, they would take a rotting plank of the ship, and they would throw it out, and then they would put in a new plank, and it would stay in the water, etc., etc. Okay. Here's the question. This is the main question. We're going to ask this over and over and again. Okay. Here's the main question. Question: is that ship with this new plank, is it still the Ship of Theseus? Now, most people would say yes. Just like if I change a tire in my car, it's still my car. Okay? But we have to go a little bit further. We have to think about it. Technically, it's not the same ship. We've changed part of it. It's not the same parts. Okay? But most people would say that it is. Okay? Great. Now, the ship is again sitting in the water over hundreds of years. More than one plank is going to be rotting away. What happens if you do 2 planks, or 3 planks, or 10 planks? Let's say the entire ship is made out of 100 planks. I just made that up. Okay? Let's say you change 10 of those planks. Okay? Take take out 10 of the rotting planks and you put in 10 new ones. Is it still the same Ship of Theseus? Okay, and this is a question that, again, if you were here, we would argue about it and we would discuss it and we would come to some conclusion. Okay, let's go on with this. Let's say you change 49 of the 100 planks. Is it still the same? Many people would still say yes. What happens if you change 51 of the 100? Now, a majority of the planks Mr. Theseus never saw. Okay, so is it still his ship? Now, obviously he doesn't own the ship, but is the idea of the ship his ship? And again, when we do this in class, a lot of people say, look, technically it's not the same ship, but it's still the same thing. People think it's the same ship. After all, on top of the museum it says, come visit Theseus' ship. It's been there. Also, there's another thing. There's a concept of gradualness. In other words, this ship has been there, or whatever has been there for hundreds of years. So fine, you made one little change, but for 50 years before that you didn't have it. So gradually these changes have been made, so maybe the idea of the Ship of Theseus continues. Okay, what happens if you get to 99 planks? You've changed 99 planks. Is it still the same Ship of Theseus? Okay, and you can argue this way and you can argue that way. Most people would say it's not the same Ship of Theseus. By the way, that brings up another question. At what point does it not? So some people would say when you get 50, in other words 50%, as long as it's 50% of the old one and 50% of the new one, that's still, you can look for that dividing point. Okay, but let's say you go further. Let's say all 100 planks were changed, but it took 1,000 years for them to change. Is the ship different now than it was? Okay, and again, these are unanswerable questions, but the question is, why are they unanswerable? Why is it so hard to answer these questions? And we're going to talk about that. Okay, all these questions are part of a philosophical question called the problem of identity. What makes something something? What makes something something? Okay, that's basically what we're asking. Okay, let's make the questions more interesting. What happens if every time I change a plank, rather than changing it, just taking a piece of wood and putting in a new piece of wood, I paint it? So it has some type of coating to protect it. But I paint it pink. Okay? Theseus' ship was not pink. He was a warship. Okay? And yet I paint it pink. Is it still Theseus' ship? Question. Okay? By the way, forget about that. Forget about changing the planks. Theseus wrote his ship. Great. I take my paint and I paint over it. I take my paint and I paint it. Let's say he's even alive. Is it still the same Ship of Theseus? Okay? Is your car the same car if you paint it? I mean, my red Lamborghini, let's say I wanted to make it yellow or something. Would it still be the same ship? Would it still be the same car? And the answer is usually most people would say yes. Okay? But it looks different. Is it still the same Ship of Theseus? And this is a question. And again, I'm not answering it. Again, in class, most of the time people would be screaming and yelling at this point and saying what they think is true and what they think is not true. Okay, let's go on to more questions. Let's say instead of changing it with another wooden plank, I put it in as a plastic. I take the wooden plank and I take it out, I throw it in the garbage, and I put in a plastic plank. So now the planks are not made of the same thing. Is it still the Ship of Theseus? Some say yes, some say no. Okay, and we do this over hundreds of years, and the vast majority of the planks are no longer made out of wood. Okay, is it still Theseus' ship? Okay, and again, this really has nothing to do with ships. You make changes to your car. You put in a new window in your house. Is it still the same thing? There's lots and lots of examples. This is you're talking about anything that you can make changes to. Is it still the same thing? Okay. You get a computer, you add different pieces. You take out the motherboard of the computer, you change that, you change this, you change that, you change the screen. There's a lot of things you can do with a computer. Is it still the same thing? Like that go. Okay, the physical objects change. Is the thing change? What I'm asking is, what is the exact definition of the Ship of Theseus? That way we'd be able to give an exact answer to this thing. Okay, is the exact definition of the Ship of Theseus the boards that Theseus held? Okay, those planks that Theseus actually put together. By the way, he didn't put it together. He had an army doing it. Okay. Some people say Theseus doesn't own it. Well, Theseus didn't own anything the day he died, because you don't own anything the day you die. Anyways, but again, this has nothing to do with the Ship of Theseus. This has to do with any object whatsoever. Any object that can be changed, and parts can be changed, and that's all objects. Is it still? For example, you have a book and the cover falls off. Is it still the same book? Okay, you have a book and 30 pages get ripped out in the middle. Is it the same book? Yes, it is. Most people would say it's the same book. It's just missing pages. But at what point is it not the same book? If you miss, let's say the book has 300 pages, you rip out 280 pages. It's only got 20 pages left. Is it the same book? No, it's a piece of tatters. Okay, well, let's just go back to the Ship of Theseus. Let's go back to the Ship of Theseus. We said if it changed its appearance, we asked the same question. If you paint it, if you change what it's made out of, okay, let's do something else. What if it can no longer float? Okay, the Ship of Theseus, its purpose was to float around the islands and the cities of Greece so that Theseus can conquer them and bring them all together. What if the ship can no longer float? And that happened actually with the Intrepid. When they took the Intrepid and they put it on the 11th Avenue in that thing, they took the engine out. There was no reason for it to have an engine. It was sitting there for years. Okay, it wasn't going anywhere. Anyways, about 10 years ago or something, they wanted to refurbish the boat. They didn't have a dock to do it. There is a dock on Staten Island to do it. So what they had to do was they had to bring the boat from Manhattan to Staten Island, in which there was a dock there that they spent a year refurbishing it. The problem was that the boat couldn't move on its own because it didn't have an engine anymore. They took the engine out, the World War II engine, they took it out. There was no reason for it to be there. Another problem was that it had sunken into the bedrock. It had been stationary for so long, it had sunk into the bedrock. So they literally had to pick it up, okay? And then they had tugboats pushing it to Staten Island. Fixed it over, and a year later it came back. Okay, but that's an interesting. Is it still a warship? It's not a warship. It's a museum. Not only is it not a warship, it can't even move. So we're changing the functionality of it. Question: if you change the functionality of the Ship of Theseus, is it still the same Ship of Theseus? It's no longer a warship. Now it's a museum piece. Okay, one last little story. This is by a guy named Hobbes. Hobbes was a philosopher, and he talked about the Ship of Theseus. The Ship of Theseus has been talked about for hundreds of years. No one's given the right definitions. No one's given the right answers. Hobbes brings in the following, and it's very, very deep, very cute. He says as follows. Let's say over the years you take the old planks and you replace them with new planks. Okay? But instead of taking the old planks and just throwing them in the garbage because they're rotted and you don't need them anymore, what happens if you take those old planks and you put them in a warehouse across town? You have an old warehouse and you put in the rotting pieces of Theseus's ship into that warehouse. Okay? And this goes on for hundreds of years, and this is a warehouse that nobody looks at, nobody cares what's inside it, etc., etc. And every couple of years or so, somebody takes a rotting thing from the Ship of Theseus and throws the rotting thing into the warehouse. Great. Years go by, and every single plank from the original Ship of Theseus has been changed. But it's been in the port of Athens for hundreds of years. And even though, because the changes have been so slow, people really think that that's the Ship of Theseus. Okay? And you can argue, a lot of people say, no, that's not really the Ship of Theseus because we never touched it, he never touched it, etc., but it is the Ship of Theseus. Okay? Now, what happens if somebody goes in to that warehouse, that secret warehouse where everyone kept the rotting things, and he took the rotting pieces of wood, okay, and he put them together? All the rotted pieces are there. Those are the original pieces that Theseus actually built his ship on. You take those rotting pieces and you put them together. Now ask yourself the following question. Where is the real Ship of Theseus? Is it in the port of Athens, or is it in the warehouse where no one sees it? Now, most people would say that it's in the warehouse. But notice what happens. Before you build it in the warehouse, most people would say the Ship of Theseus is in Athens, is in the port of Athens. But then he builds it, no one else sees him build it, and automatically its status goes, that's no longer the Athens, the port one is no longer it, the warehouse one becomes it. And that's a very interesting thing. It's strange, but interesting. Okay. And again, if we were in a classroom setting, there would be a major battle now about which one is the real Ship of Theseus. Okay, there's another thing called the Acts of George Washington. Okay, George Washington is famous because he said, "I cannot tell a lie, I chopped down the cherry tree." So there's some museum that actually had George Washington's axe. Now an axe from that generation is made out of two pieces. There's the wood handle and there's the iron piece of metal that chops. Okay, so it's not made out of 100 different planks. It's made out of two things, and the wood rots every 50 years or so, and the metal rusts every 20 years or so, and so they have to be replaced. But now, every time there's a replacement, you replace the wood or you replace the metal, you're replacing 50% of the thing. It's not like you're replacing it's not like you were doing in the Ship of Theseus, where you were replacing things once every a long time. This is a more this is not a gradual change. Every time you make a change, you're changing 50% of the thing. Okay, so, question. 150 years go by, George Washington, his axe. You've changed the wood 3 times. You've changed the metal 2 times, or something like that. Question, is it still George Washington's axe? Yes or no? Okay, and again, it's the same question. We can't answer that question. Okay, these have no real answers, but I want to say it doesn't go only on physical things, it goes on abstract things also. For example, and in class I do this usually for a half hour, what makes Brooklyn College, the college where this class is taking place, what makes Brooklyn College Brooklyn College? Let's go through it. The students change, the faculty change, the secretaries change. By the way, the secretaries last longer. Students get changed every 4 or 5, 6 years. The faculty changes every 20 or 30 years. Okay, the secretaries, there are some. I've been here since 1985. The secretaries, some of the secretaries are still the same. Maybe not anymore, but 10 years ago for sure, I knew some of the secretaries who have been there since I was a student. So things change. Okay, the classes change. In other words, what they're teaching has changed. The rules about it change. The computer department for sure changed. So what makes Brooklyn College Brooklyn College? Brooklyn College was not always in the middle of Flatbush. Okay, it was in downtown Brooklyn for a long time. So it's not the place. The buildings change. There used to be a plaza building that was on Bedford Avenue. It was knocked down. The Webb building is a totally new building. The East Quad building is a totally new building. I usually go through a little history of what why the buildings look the same, why the James building is different. Okay, basically the college was built in the 30s, and then in 1939 we ran out of money because we were starting because of World War II, and so that's why they ran out of money. But it's a nice, interesting thing. Okay, let's talk about something else. Let's talk about the New York Yankees. The players change, the owners change, the fans change. It's still a baseball team. It still follows the rules. The uniforms change. They haven't won a World Series since 2000, so they're not really the same team. Okay, what makes the New York Yankees into the New York Yankees? That's a question we could ask. Okay, and again, when there's a lot of students, we usually have a lot of different answers to this, and no answer is absolute. Okay, by the way, Yankee Stadium, or Shea Stadium moved. Okay, Citi Field is no longer in the same place where it was. I'm not sure about that. Another abstract idea. So Brooklyn College is an abstract idea. It's not, I mean, you can kick the building of Brooklyn College. That's not what Brooklyn College is. Okay, it's an abstract idea. The Yankees are somewhat of an abstract idea. Another abstract idea, the U.S. government. What makes the U.S. government into the U.S. government? Okay, it changes. Every 4 years there are elections. Every 2 years there are elections. Okay, and its policy changes. Its leadership changes. Its policy changes. The U.S. government is not the Capitol building. It's not the Supreme Court. It's not the White House. What makes U.S. government into the U.S.? Again, it changes its policies. Okay? In fact, a large part of the Constitution is to insist that somehow the policies continue. So if someone makes a treaty, it's hard to break the treaty. Okay? Because they knew, the founders of the Constitution knew that of this problem, that things have a hard time continuing. Okay? The Supreme Court, the purpose of the Supreme Court is one president puts on people on the Supreme Court, and he stays like that so that the president doesn't control the Supreme Court. So again, the founders of the Constitution understood the problem of Theseus' ship and tried to somehow manage those changes and to see how they do. But again, what makes the U.S. government into the U.S. government? Okay, all these questions are very important, and we'll deal with them, but now we have to even ask a more profound question. We have to start talking about human beings. Okay, while the question of identity is very interesting about the Ship of Theseus, it gets even more interesting when you talk about human beings. Okay, and there philosophers call it the problem, not of identity, of personal identity. Okay, and here we ask, what makes a person a person? What makes somebody themselves? In what way are you different? In what way are you the same as you were 5 years ago? Okay. Now again, this is a million questions, and usually I teach this, takes an hour or two just for this section alone. People have a lot of things, but it's not going to go, because there's no other people here, it's going to go a little bit quicker than it should. Okay, whenever I ask this question, I usually get one of three answers. A person is their body, a person is their mind, or a person has a soul, whatever that means. And we have to go through that. Okay, so let's talk about it. Okay, first of all, is a person their body? Okay, well, this is my body. Is this me? Okay, so before we even talk about that, you have to realize the following fact. Every cell in your body dies and changes over a 7-year period. Again, it's a gradual change. Okay, it's a gradual change like the Ship of Theseus, but still it's a change. In other words, you do not possess any cells from your body of 7 years ago. So, in what sense are you the same person? For example, if you kill someone, or you were sentenced to jail, should you still stay in jail after 7 years? Since it wasn't you, it's not your body. Okay, somebody else killed somebody. Okay. What about owning something? If you own a car, do you still own it after 7 years? It's not you anymore. So why should you still say you own it? Okay. More questions of this form. What happens if somebody amputates a leg, or 2 legs, or 4 limbs? Are they still the same person? They don't have the same person. They don't have the same body parts. How about an amoeba? An amoeba is a one-celled organism that doesn't have sex. It splits apart. So question, who's the mother, who's the daughter? How old is your amoeba? Because was it part of the previous amoeba? In other words, before it split up, so then it's thousands of years old. Okay, and you have basically the same problems. If you say that a person is their body, you have the same problems as the Ship of Theseus. The Ship of Theseus, the problem was that the ship constantly changes. Well, your body's constantly changing. So what makes you still the same thing? Okay, a few more questions about saying it's the body. Okay, one question which I really don't like to talk about in class, but it has to be talked about. Abortion. Are you this? Is the bag of cells inside your mother's stomach, is that a person or not? Okay, and people who argue over abortion, which is not what we do in this class, they argue about that. Is it a living thing or is it not a living thing? Okay. So again, the definition of what makes a human is not clear. It's not an obvious thing. People argue about that all the time. Okay, and it's not even clear, even if they had, there is no exact definition, just like there was no exact definition of the Ship of Theseus. There is no exact definition. That's why people can argue. But definitely don't want to get into that. Okay, let's talk about something else. Well, let me just recommend that you watch. There's a 50-minute documentary worth watching on YouTube. It's about Abby and Brittany Hansel. They are conjoined twins. Okay, they have 2 heads, or she is one person or 2 people, 2 heads, 2 feet, 2 arms, and they're growing up, and it's describing how they're growing up and things like that. The documentary is about 20 years old, but it's an interesting thing. It makes you question what a human being is, or is that one person or is that 2 people? Okay, I strongly recommend that you watch it. Okay, next, if a person's their body, okay, and they die, do you say my grandfather's buried in Queens, or do you say my grandfather's body is buried in Queens? In other words, is your grandfather the same person, the same thing as their body? So we have to talk about that. If a person is their body, then you can say my grandfather's buried in Queens. I found that people use both phrases equally. Okay, great. So body is not really the answer to the question. What makes a person, their body? No, that doesn't work. Okay, let's go through another possible answer, and that is mind. Okay, now what's going on inside your head is this voice is going on for years and years. Okay, this voice is going on. So you have a state of mind, and that's pretty much continuous, although it stops every night, right? When you're dreaming, you don't have a continuous state of mind. You have some crazy person making up these dreams, okay? But a person is their mind. It's their stories that they tell. It's the voice in your head that's somehow unique. That is a typical answer. Okay, now we can ask a lot of questions. For example, if you have dementia and you start losing your mind, are you no longer that person? Okay, what about Alzheimer's, which is more severe? People forget who their own children, they forget their own name. Okay, are they still the same person? And most people would say, oh, they're the same person, they're just sick. But fine, but that doesn't answer the question. Are they the same person? And again, when we have people here, we fight about it. Okay, let me tell you another problem. Let's say that's me now. I remember where I was 10 years ago. And I was teaching, and I basically had the same political views, and I had the same personality, etc., etc. So I'm kind of the same now as I was 10 years ago. Now, 10 years ago, had you asked me how I compared to 20 years ago, I'd give you the same answer. Okay? 10 years ago, I was about the same person as 20 years ago. However, and I do about with this curly equal signs. However, if you ask me, and I remember what I was like 20 years ago, how I compare 20 years ago, I'll tell you absolutely positively, I'm not the same person as I was 20 years ago. Okay, so this is an interesting thing. He is almost the same as him. He is almost the same as him, but he is nothing compared to that person. Okay, so this is called transitivity of identity. Why isn't this working? Okay, and the answer is because, yes, I'm close to what I was 10 years ago, but not exactly the same. And he is close to what he was 20 years ago, but is not exactly the same. But the combination of not exactly the same twice, you get something totally different. So that's interesting. Okay. Okay, great. If we're saying that a person is their mind, what about animals? Do animals have a mind? Most pet owners would say yes, okay, especially dog owners and cat owners, okay? Do their minds, well, what about a fish? Does a fish have a mind? Most people would say no, I guess. Okay, I want to tell you another story that is told in every psychology class. Phineas Gage. Okay, so it's a cute little story. It's a horrifying story, but it's a story. Okay, and it's interesting, and it has to do with the mind. You ready? So Phineas Gage worked in the railway in the 1880s or 1810s, I'm not sure. Okay, and part of working in the railway was he was working in getting rid of stones along the way. In other words, if the train was going, if you had a big boulder, rather than the train going around the boulder, which would slow the train down, you want the train to go as straight as possible. So if you have a mountain there, you want to blow up that mountain, you want to get rid of the boulders, you want to get rid of the mountains. Okay, and he worked with this thing. Okay, so what happened was as follows. The way you do that is, how do you get rid of the boulder? You can't just push it. Okay, what you have to do is you have to blow it up. And you blow it up not by strapping dynamite to it, because then it would just, it's a stone. It would just, it doesn't take an interest. What you do is you take a metal stake and you bang the metal stake into the stone. Okay, and then you put a piece of dynamite inside the stone, light the dynamite, and then the stone blows up from the inside out, and that gets rid of the stone. Okay? And Phineas Gage was doing this, and one day he was knocking in a metal stake into the stone, okay? And he didn't realize that somebody had put in a piece of dynamite in there already. And the metal stake, he knocks it in, it lit the dynamite, and it flew out. And it flew out and flew right through his head. Okay, it went through his head and out the other side of his head. The amazing thing is that Phineas Gage survived. Okay, he lived for another few years. Okay, and they know exactly what part of the brain it affected, because when he died, they kept the skull. And the skull, you can see it in psychology textbooks. The skull has a hole over here and a hole over here, and you can see where it went in and where it went out, and what part of the brains it affected. The main idea is that Phineas Gage was not the same person as he was before the accident. Before the accident, he was a nice, friendly guy that everyone liked and everyone was friendly with. After the accident, he cursed and spit and fought with people and cheated on his wife, etc., and did nasty things. I made up the part about cheating on his wife. Okay, and what people usually say is that he lost his inhibitions. Phineas Gage lost his inhibitions. Okay, so his state of mind changed. Question: which is the real Phineas Gage? The one beforehand or the one afterwards? Especially if you say that this mechanism in the frontal lobe was the thing that was lost. So what's the real Phineas Gage? The one with the frontal lobe or without? In other words, the one with his inhibitions, where he's controlling himself, don't say that, don't curse, don't do that, whatever, or the real Phineas Gage is the one that's really doing this. You can do this same experiment with a bottle of tequila. Take a bottle of tequila, drink it, okay, and ask yourself the following question: who's the real you, with the tequila or without the tequila? Don't answer it. Anyways, so those are the types of questions that people ask. What happens when a person has a stroke? Are they the same person before and after? And people do change when they have a stroke. A doctor told me about 20 years ago that until 20 years before that, every time somebody would have an open heart surgery, they didn't have the oxygen right. They didn't know how to deal with the oxygen as well as they do now, and people would come out differently when they had open heart surgery. Okay? In other words, they had lost oxygen while they were there. So are they the same person or not? Their mental state is totally different. Want to talk about something else. Still talking about strokes. I want to talk about this. This is an amazing Jill Taylor. This is an amazing TED Talk that's worth watching. Okay, Jill Bolte Taylor. You'll type in the name. It's called Stroke of Genius. Jill Bolte Taylor had a stroke one day. Okay. But she's different than a lot of other people because she is a neurologist who studies the brain all the time. And so while she's having this stroke, she's understanding what's going on, what part of her brain is taking over what's going on. And she describes this, okay? Because not only did she have a stroke, she's a neurologist who had a stroke, not only did she had a stroke, but she remembered it and she recovered from it, and she was able to write a book about it. The book is called Stroke of Genius, and you can read. It's a 16-minute TED Talk. It's worth watching. Watch it. Okay, some more things. What about people with multiple personalities? It's a real thing. People have multiple personalities disorder. Okay, who are they? Okay, which person are they really? Okay, a million other questions like that go on. Okay, I want to talk about something else. Don't move, don't move. Okay, a person's brain, you should definitely watch those two videos. A person's brain is made out of two hemispheres. Okay? And they're connected by this little thing called the Corpus Callosum. Okay? And they help the two hemispheres communicate with each other. Great. Certain people in the 50s had operations where they had to cut this. They were having seizures, and the seizures happened because these were, and so what they did was they cut these things, okay? And the two hemispheres were now separate. But the two hemispheres were actually able to communicate because what this one would say, they would hear, and that one would listen, okay? But people did experiments with these, and these are called split brain experiments. Don't move. You can see it over here. they would sit a person here and they would put a partition, and so what this side of the brain could see, this side of the brain couldn't see. Okay, and they asked this side of the brain what he sees, and he would respond one way. And if they asked this side of the brain what he sees, he would respond the other way. There are two human beings in every person's body. One is the left side of the brain, one is the right side of the brain. The amazing thing is that they communicate, and it sounds like one person, but there is no one person. There are actually two brains inside of you, and they're not always working in tandem. And that was what this article is all about. So, split brain experiments, a fascinating topic. Okay, lots of different types of things, and all these things are showing is that person is not their mind. The mind is independent of the person. Okay, so it's not your body and not your mind. And we can talk about a soul. Okay, I'm not going to spend a lot of time talking about a soul because I don't know what a soul is. Okay, but we can ask the same question about a soul. For example, does the soul change over time? Okay, and if you say yes, then we can ask the same question. So, what makes you you? If the soul is changing, what makes you you? And if the soul is not changing, then what relationship does it have to do with you? Because you are constantly changing. Every person is constantly changing. So what connection does this non-changing soul have with this person? What influence can it possibly have? Okay. So, but I don't want to get into that. I don't know, again, I don't have a good definition of a soul, so I don't know how to deal with it. And again, it doesn't belong in a science class, not that it can't, but we don't have a thing. Okay, so, body, mind, soul. Usually, if I asked you who you are, you'd say some unit, some union of all these three different ideas. Okay? And it's not clear what you mean, etc., etc. My point in all these things is it's not clear who you are. You're changing, you're constantly changing, and you should continue to change, but it's not clear who you are, and there's no exact definition of who you are using any of these things. Even a combination of them, it's not so simple. Okay, now we dealt with the question of identity, we dealt with the question of personal identity, and now I'd like to pull back and ask the following question. Why is it so hard to give a damn answer to these questions? I spent the past hour asking you a million different questions. Why is it so hard to find an answer? And the answer is that there are no exact definitions of these things. Okay? We don't come to life with exact definitions of things. Okay? We don't have an exact definition of what we mean by a Ship of Theseus. We don't have an exact definition of what we mean by the Yankees. We don't have an exact definition of what we mean by you, what makes you you. Okay? There are many different possible answers to those questions, and there are no exact answers to them. Okay? When you're growing up as a child, your mother's feeding you what you'll call applesauce. Okay? She doesn't say, oh, this is applesauce. Well, maybe she does, whatever. But you don't have exact definitions of other things. For example, a chair. Does a chair have, what's the exact definition of a chair? Does a three-legged stool, is that a chair? Okay. If one leg of a four-legged chair is broken, is it still a chair? There are no exact definitions. Definitions are not these exact things. And so there's no exact definition of the Ship of Theseus. There's no exact definition of you. There's no exact definition of things. Okay? And it's hard to say that they really exist because you can't give exact definitions of what they are. Okay? The Ship of Theseus, did it change or did it not change? Are you the same person as you were 5 years ago? I should hope not. Okay? But yet you are the same person. So how does that work? Okay. again, I'd like to go back to ancient Greece. In ancient Greece, there was a great man named Plato. Okay? And Plato believed that abstract ideas really exist. He felt that the concept of beauty absolutely positively exists. He felt that the concept of threeness absolutely exists. There's an idea of three, and if you have three different markers, that's going to correspond to this idea of three. Okay? So the abstract idea of three really exists. The abstract idea of what is good really exists for Plato. Okay? He said, these are not just things that people talk about, they really exist. And philosophers are the ones who should tell you what they really are. So, Platonism. He started a school of thought which we call Platonism, and that idea is that abstract ideas really, really exist. They really are out there, and human beings deal with them. Now, not everybody was a Platonist, even back then. Not everybody agreed with Plato, and the opposite school is called Nominalism. Nominalism from the word name. Nominalism is just says, you know what, these things don't really exist. They're just names we give it. So beauty doesn't really exist. Beauty is not objective, Mr. Plato. They're just something that people say, oh, that's beautiful. And we kind of agree on sometimes we kind of agree on what's beautiful, and sometimes we don't. Okay? And the number three doesn't really exist. The number three is just something that people talk about. Oh, there's three, there's another thing that's three, etc., etc. Okay? It doesn't really exist. So that's what nominalists would say. Platonists would say these things really exist. A Platonist would say, long before human beings ever existed, two dinosaurs went into a field with two dinosaurs, and there were four dinosaurs. Conclusion, 2 + 2 is equal to 4. Okay? They would say, mathematics is true, absolute. Okay? The abstract ideas in mathematics are absolutely true. The nominalists would say, it's hard to say. Okay? They don't really exist. What really exists, they wouldn't. Okay? Now, Platonism and nominalism, they were all about abstract ideas. Okay? But we weren't talking about abstract ideas. We were really talking about the Ship of Theseus. Okay. Now Plato, oh I'm sorry, I'm going to talk about people who I would call extreme Platonists. They would say, and there's always one in the class, they would say, you know what, there is an exact definition of the Ship of Theseus. There is an exact definition. You, Yanofsky, you just don't have the exact definition. But it doesn't mean that it doesn't exist. People are arguing about it because they don't know the right answer. But there is an exact definition of the Ship of Theseus. There is an exact definition of what Brooklyn College is. There is an exact definition of what the U.S. government is. Just we don't have it. Okay? That's what they would say. That's what an extreme Platonist would say. He would say, not only do abstract ideas exist, but concrete ideas also exist. Okay. What I've been pushing is something along this way. Extreme nominalism. Okay? And what this says is, not that abstract ideas don't really exist, but even concrete things like the Ship of Theseus, like Brooklyn College, like your car, where you change the tires, even that doesn't really have an existence. There are things that people can talk about. There are things that say, oh look, there's a sign that says Theseus' ship. Let's go visit that museum today. We agree to call it that, but that doesn't mean it's really Theseus' ship. It's made out of plastic. It's not really his ship. He didn't touch those things. Okay? So what I've been pushing more is extreme nominalism. Extreme nominalism says not only do abstract ideas are just names, but even concrete things, things that you can kick, they don't have exact definitions. They don't have exact, you can't say they exist. they're things, okay, and they put together by you, okay? So that's extreme nominalism. That's the idea that we're talking about. Now, there's a few interesting points about this. For example, take the number 42. We were talking about the ship of Theseus, and we said, what happens if you take off a plank? Is it still the ship of Theseus? Take the number 42. If I take off one of them, I get 41. We all have to agree with that. If you don't think that 42 minus 1 is equal to 41, you belong in a lunatic asylum. Okay? So, in some sense, the number 42 has a more exact definition than the ship of Theseus. That's an interesting point. Okay? The abstract idea of 42 has a more exact definition than the real ship of Theseus. The ship of Theseus that you can touch and taste and look at, that doesn't really exist. But the abstract idea of 42 plus 5, 47. Okay? We can have exact definitions about abstract ideas. It's harder to have an exact definition about concrete things. So that's an interesting thought. Anyways, the book has a lot of more ideas in there, and it's worth spending time reading. Okay, so let's go on to the next section. Next section is section 2, and it's about Zeno's paradoxes. Mostly about Zeno's paradoxes. So, again, Zeno is somebody who lived about 2,500 years ago, and Zeno is a student of Parmenides. Okay? Parmenides was a philosopher or a mystic, and Heraclitus was a philosopher or a mystic. And they had two different worldviews. Let's talk about Heraclitus. Heraclitus said the world is constantly changing. We talked about that 2 minutes ago, about how things are constantly changing and moving, etc., and how they're different than they were. Heraclitus says it's hard to step in the same river twice. Okay, think about it. What's the definition of a river? Has the water in it? Well, the water moves on. So what makes a river a river? So he said it's hard to step in a same river twice. But Heraclitus would say everything is in flux, like we said 20 minutes ago. As opposed to that, Parmenides said, no, everything is a unit. Everything is one. All is one. He was some type of mystic who, would be more mystical, and there's, a unity in things, and although it looks like things are changing, but really they're really the same. Okay? Zeno was a student of Parmenides, and he wanted to show that Parmenides was right. Okay? And what he did was he made a few thought experiments, and he showed what it means. Okay, so imagine the following. Here's a man. Here's a door. And he's walking towards the door. Now let's say there are 16 feet from here to here. Okay? In order to reach the door, he has to pass by a halfway point, which is 8 feet. So again, the whole thing is 16 feet, and he has to pass by a halfway point. In order to get from here to here, he has to do a halfway point. Okay, once he's here, he's got 4 more feet to go. Okay? I'm sorry, he's got 8 more feet to go, but in order to do that, he'd have to pass by the 4-foot boundary. In other words, in order to go these 8 feet, he has to first do 4 feet. Okay? Once he's here, he has to do 2 feet. He has to pass the 2-way point. Then he has to pass the 1-foot point. Then he has to pass the half-foot point. Then he has to pass the 1/4-foot point, etc., etc. The point is that for this guy, to hit the door, he has to do an infinite process. He has to go past this 8 point, he has to pass the 4 point, he has to pass the 2 point, he has to pass the 1 point, a half, whatever, half a foot, quarter of a foot, etc., etc. This goes on forever and ever. Okay? Now, we know that one cannot do an infinite process in a finite amount of time. Okay? You have a list of things you want to do on the day. It's a finite list. You complete the list or you don't complete the list, whatever. But you can't do an infinite things. And yet, there's an infinite amount of things done here. Okay? Now, there's another way of looking at it also. Okay? By the way, the same thing here. That's the refrigerator. It would have to do an infinite process to do it. I'd have to go halfway, and then a quarter of the way, and then an eighth of the way, etc., etc. But in fact, I can do it. Okay? So there's something wrong with Zeno's rationale. There's something wrong with the way Zeno's describing this problem. There's something wrong with it, because on the one hand, you can't do an infinite process. On the other hand, a person does do infinite processes. Well, let's look at it another way. In order to get from here to the door, he has to go 16 feet. In order to do that, he would first have to do the 8 feet. Okay? Well, in order to do the 8 feet, he would first have to do 4 feet. Okay, so this is 8, this is 16, this is 4. In order to get to the 4 foot point, he would have to do 2 points. He would have to go 2 feet, etc., etc. And 1 1/2 and a quarter, etc., etc. So another way of looking at it is he'd never get to the door because he'd have to do an infinite process even to get to the door. Okay? He might as well just stay where he is because it's an infinite process no matter how far he has to do, because you can always split how much you go. Okay? Okay, so this is Zeno's paradox. It's called the dichotomy. Okay, because from the word split, die is 2. You're splitting things into 2 and 2. Okay, and it's been around for 2,500 years, and nobody really has a good answer to it. Okay, but first I'd like to show you something in math. Okay. The thing in math is as follows. And I'll show you how it's related in a second. Let's say I ask you what's a half plus a quarter plus an eighth plus a 16th plus a 32th plus a 64th plus ... Okay? This is exactly what he has to do. In order for the man to get to the door, he has to go a halfway point, a quarter of the way point, an eighth of a way point, and then he does a 16th of a way point. How much is this equal? Okay? Now, the usual answer to this is, look, it says plus ... which means I'm going to continue to add more and more to this. Okay? If you can continue to add more and more to it, then you're never going to stop. So it's infinite. Okay? Plus means you continue. Yes, you're adding smaller and smaller, but you're adding infinite. Okay? You're always going to go on, so it's going to be infinite. That's the first reaction. But I'd like to show you mathematically what this is really equal to. Okay? I don't know what it's equal to, so I set a variable equal to that. I say, look, what is x? Okay? X is equal to this. Now tell me, what number is x? Okay. Now, I can't tell you what x is, but I can manipulate x. Okay? I can manipulate x. So one thing I can do is I can multiply x by a half. Okay. Now let's just go to the side and remember what multiplying by a half is. If I tell you a half of a plus b, okay, you can write that as a half a plus a half b. Okay? That's called the distributive property. So I'd like to distribute this half along this whole thing. Okay, and so we get a half times a half is a quarter. A half times a quarter is an eighth. A half times an eighth is a 16th. A half times a 16th is a 32th. A half times a 32th is a 64th. And it goes on forever and ever. Great. Now, what's a half x equal to? I don't know. Okay? I don't know what x is, and I don't know what half x is, but this is true. Okay? Now I want to do something else. I want to subtract these two. These are both equations. Okay? And I want to subtract this minus this. What's an x? Take away a half x. You have a box of oranges. You take away half of the oranges. What are you left with? The answer is a half x. Okay? So that takes care of the left side of the equation. And now I want to do the following. I'm going to subtract this whole thing, take away this whole thing. So a quarter minus a quarter, that cancels out. An eighth minus an eighth, that cancels out. A 16th minus a 16th, that cancels out. This goes on forever and ever. Okay? Forever and ever. Anyways, at the end, what are you left with? A half. That's the only thing you're left with. Okay? Now ask yourself the following question. What's x equal to? Okay? Multiply both sides of the equation by 2, and you get x is equal to 2 over here, 1. Okay? And that fits in with Zeno's paradox, because if you do a half, and then you do a quarter, and then you do an eighth, and then you keep on getting closer and closer to the door, eventually you will hit the door. Okay? That's a mathematical explanation of what Zeno did. But that's not really good. You see, I didn't really add up all the pieces. By the way, you could do that. You could take a calculator, add 0.5 plus 0.25 plus 0.12, 0.125, keep on adding. But if you keep on doing that, you'll never finish, because it says go on forever. Okay? But we did this little mathematical trick, and we showed that x is equal to 1 if you do it in math. Okay? I'd like to show it to you more geometry, a geometry way of looking at this same thing, and you see it a little bit clearer. Take a square, 1 foot by 1 foot, okay, and color in a half a foot. Okay, you have half a foot colored, a half a foot not colored. Now color in a quarter of a foot. So take the half that's not colored, okay, split it in half, and color in a quarter. So this is a half, this is a quarter. Now take the quarter that's not filled, split it in half, and fill that in. Okay, that's an eighth. Okay, keep on doing this. Split and fill in half. So this is 1/16, and this is 1/34, and this is 1/64. Okay, question. Keep on doing this. Dot, 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 dot. Okay, keep on splitting in half, splitting in half, and splitting in half. At the end of doing all of this, how much is shaded in? Answer, 1 by 1, the entire thing. Okay, it's never going to go past this and get more than 1. So the thing is 1. Okay? So a half plus a quarter plus an eighth plus a 16 is equal to 1. Okay. Okay. So, what's the solution to Zeno's paradox? There is no solution to Zeno's paradox. Again, Zeno shows that movement is impossible, that there's no change, people can't move, everything is the same, and yet movement is possible. Okay? Okay. There's no real solid solution to this. There is one interesting thing that people bring up and physicists talk about today also. Okay? We usually think as space as continuous. In other words, from here to here, look, my hand is going softly, continuously from here to here. Okay? And we think of continuous as the real line. This is what your teacher drew the first day of 9th grade, the real line. And the real line has the property that between any 2 points, you can split it in half, 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 just like Zeno does. Okay? Very nice. But we get into a problem because then we're doing an infinite process. Okay? So that was the problem with Zeno. But there's another way of thinking about it also. You're all now watching this video on a computer screen. The computer screen is made of many pixels. Okay? And if you want, you can think of the man in the door. And if you went and you counted how many pixels, you would say, let's say from here to here is 10,000 pixels. Okay? In order to do that, you'd have to cross over 5,000 pixels. In order to do that, you'd have to cross over another 2,500 pixels. In order to keep on going, you'd have 1,200 pixels, 600 pixels, 300 pixels, 150 pixels. But eventually, you'd get very, very close, and there would be 4 pixels between you and the door. Okay? Then 2 pixels between you and the door. Then 1 pixel between you and the door. And then pixels cannot be split. A pixel, every pixel is one particular color. You cannot split a pixel. Conclusion, after you have 1 pixel away, you then touch the door. In other words, when you're dealing with the real line, okay, then you can always split in between. But if you're talking about pixels, then there's some finite point where you can't split any further. And that point you will touch, you will get to there. Okay? So people theorize and say, look, the problem is because you think we live in a continuous world, but maybe we don't live in a continuous world. Maybe the world that we live on is somehow more like a TV, and we're we're discrete, separated. Okay? So rather than saying space is continuous, we say the space is discrete, chopped up into little pieces, and at some point there are little space atoms that you can't chop up any further. Okay? That would solve the problem, because then going 10,000 pixels means you have to do 10,000 things, and you can do 10,000 things, okay, if they're small enough things. You can't do an infinite amount of things, but you can do 10,000 things. So, if the universe is split up with these little space atoms, then maybe that would explain Zeno's paradox. And you've seen this before when you were in high school, chemistry, talked about the nucleus of an atom, and you had these little electrons flying around in the shell of the atom. Okay? And your high school teacher said to you, this electron is here, or it can pop down there, but it's not in between. Okay, now what does it mean? How does it get from here to here and not go in between? And the answer is, I don't know, that's quantum physics. But the point is, somehow the universe is made up of these discrete little separated points, and there's nothing in between. Okay, so that solves the problem. And that would solve the problem if we know this to be true. Okay, so Zeno's problem would not be a problem if the universe was discrete. It doesn't look discrete, right? It looks continuous. It doesn't look like I'm going there, here, 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 here. It looks like I'm going continuous, but looks are deceiving. Maybe. Okay, great. Okay, Zeno had a few paradoxes. We're going to go through 3 of them. The next one is called Achilles and the Tortoise. Okay? Achilles and the Tortoise. So, let me tell you who Achilles is. Achilles is the ancient Greek version of Flash from DC Comics. he was the fastest man on earth. He can run very fast and whatever. He was a superhero. Okay, they made comic books out of him. That was Achilles. Now, as opposed to that, a tortoise is a giant turtle, and if you've ever seen them, they walk very, very slowly. Okay? One day, Achilles meets the tortoise and says, "Let's have a race." Okay? The tortoise says, "Achilles, you're the fastest man in the world. I'm the slowest animal. You'll definitely win me. But give me a head start and maybe I'll do better." Okay? So Achilles agrees to it. So let's say this is the finish line. Okay? Okay? And here you have Achilles. And here you have the tortoise. Oops. That would be a regular race. But Achilles, being a gentleman, gives the tortoise a head start. Okay, now before we start, who's going to win? Anybody with half a brain is going to say, look, Achilles is going to go and he's going to pass over the tortoise and he's going to get to the finish line very quickly, a lot quicker than the tortoise. Okay? No matter how big of a head start the tortoise has, Achilles will win. Okay, that's the usual way. But Zeno describes this paradox in a certain way that shows that Achilles will not win. Let's look. Okay? Look, in order for Achilles to get from here to the ending point, to the finishing point of the race, he has to pass by where the tortoise was. Okay? Here's Achilles. He has to pass where the tortoise was. Okay? Now, in order for him to do that, he has to it takes time, a short amount of time, for him to go from here to here. Very good. Okay? But in that time, okay, again, the guy shoots a gun. Achilles hears the gun. He goes from here to here. The tortoise also moves a lot slower, but in the time that it took for Achilles to go from here to here, the tortoise went from here, let's say, to here. So obviously Achilles is very fast, so this is going to be, let's say, let's even make this even a little bit smaller because the tortoise is not that fast. Okay? But in the time that Achilles went from here to here, the tortoise went from here to here. Okay? Great. So now the tortoise is here and Achilles is here. Great. In order for Achilles to win, he has to pass where the tortoise was. He goes past where the tortoise was, okay? He'd have to go from here to here. Now, that's a very short amount of time. It's even shorter from here. But in that time, the tortoise went from here to there. Okay? Again, imagine just for the math's sake that Achilles is 10 times faster than the tortoise. Okay? So that's not up to par, but something like that. Okay? The pictures are not drawn to scale. Okay? Now Achilles is here and the tortoise is here. In order for Achilles to pass the tortoise, he has to go till here. Okay? In that time, the tortoise moved up a little bit. Okay? Now, admittedly, Achilles is getting closer and closer and closer and closer to the tortoise. But he's never going to overtake the tortoise. Why? Because every time Achilles gets to where the tortoise was able to move up a little bit. A little bit. And so it goes on like that. Okay? Conclusion, Achilles will never win the tortoise because as he's getting closer, anytime he is getting closer, the tortoise is able to move ahead. Now again, it doesn't make sense. We all know that eventually Achilles is going to win the tortoise. So there's something wrong with Mr. Zeno's logic. And the question is, what's wrong with it? Okay. Now again, if we think of space as the real line, so even if he's catching up. He's going 10 times faster, and he's going 10 times faster and 10 times faster. But you can always chop a number into 9 parts and a 10th part. So you can always keep on chopping this number in half and in a 10th and a 10th and a 10th and a 10th, just like you did with the dichotomy puzzle. Okay? So one of the problems, and why it would take an infinite amount of time for Achilles to overtake the tortoise, is if you think of space as split up like that. Okay? In contrast, let's say you're watching this race on a TV screen with little pixels. Even if you get a high definition TV, it's still made out of little pixels. Pixels can be this color or that color. You can't split a pixel in half. Well, just think about it. Let's say you start off that there are 10,000 pixels between Achilles and the tortoise. Okay? Well, the next time, because the Achilles goes 10 times faster than the tortoise, by the time Achilles catches up to where the tortoise was, their difference will be 1,000. You went from 10,000 pixels in between them to 1,000. The next time you do it, there'll be 100 pixels between Achilles and the tortoise. The next time you do it, there'll be 10 pixels between Achilles and the tortoise. The next time second, there'll be 1 pixel between Achilles and the tortoise. Okay, now, what happens the next second, let's say? Okay, there was only 1 pixel. You can't say, oh, next you take a 10th of the pixel. Pixels don't split. Okay, so the next time you do 1 second, and already Achilles is ahead of the tortoise, or in the same place as the tortoise. He overtook the tortoise. Okay, so again, if you think of the world as continuous, you have a problem. But if you think of the world as chopped up into little space atoms, you don't have a problem. Okay? So that's the second thing. It's basically the same paradox as the first one. Okay, great. Next. Okay. The next paradox is called the arrow paradox. Okay. And it goes like this. Take an arrow, shoot the arrow. Okay. If you want, let's draw a little man. Okay. And he has an arrow, and he's shooting the arrow, and here's a target, and he's shooting the arrow. Okay? Now, think of the arrow is going straight to the target. Okay? And if again, you can think of time, not space, time, as the real numbers. Okay? We think of time as the real numbers. We watch time pass by, and at every point, let's say this is the arrow here is at t0, and here the arrow is at t, I don't know, 10 seconds later, he's out there at the thing. So at every point in time, the arrow is one place. Okay? The arrow is here, let's say 5 seconds later, 2.3 seconds he's here, 7.8 seconds he's here. At every second, at every moment, at every exact place in time, the arrow is at one particular position. Okay? Now Zeno asks the following silly question. You ready? When does the arrow move? It's a seemingly silly question. When does the arrow move? Okay? If at every point the arrow is in a particular place, when does the arrow move? Okay? It's a strange question because we don't think when an arrow moves not at a particular moment, but it moves over time. So it's a strange question. But it's a good question nevertheless. Okay? If at every moment, at every instant of time, the arrow is in a particular place, when does the arrow move? Okay. Now, think of this now, not as if, let's look for a solution. Think of this now, not as watching it on TV, but think of it as watching it on a movie. Okay? Now you know movies are made out of movie frames. Okay? The arrow is, okay? So let's say there's green arrow is firing his arrow on a movie frame. Okay? Classical movie frame. Okay? So what happens in the movie frame? Well, the arrow on the one frame is over here. In the next frame it's over here. In the next frame it's over here. In the next frame it's over here. Okay? We don't see that, okay, because our eyes are somewhat limited and we see only continuous motion. We see the arrow moving slowly and carefully. But if you took out the movie frame and you actually looked at each frame, you'll see here's the arrow is over here, the next frame the arrow is moved over, the next frame the arrow moved over, etc., etc. So if we look at it from the movie point of view and we ask the question, when did the arrow move? The answer is in between frames. In between frames, that's when the arrow moves. A movie is made out of a series of pictures. And in the pictures, nothing moves in the pictures, but between taking the pictures, the arrow moves. Okay? And that would answer Zeno's question, and that would make sense. Okay? The problem is, we don't see the universe like that. We think the universe is set up like the real line. Time is set up like the real line. Only when you're dealing with a movie is time split up into frame, 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 frame. Okay? So that's an interesting point. So again, if you think of time as continuous, you have this Zeno's arrow paradox, which doesn't make sense. Okay? When does the arrow move? But if you split up time into little chunkets, into little time atoms, then you have a solution. When do things move? In between the time arrows. Now, it doesn't look like the universe is split up like that. It feels like I'm talking continuously. It feels like things are flowing smoothly. It doesn't look like this. In other words, think of your watch. Okay? Some types of watches go like that. By the way, in the movies in the 1920s and the 1910s, if you watch Charlie Chaplin, you see people walking funny. Why are they walking funny? They walk the same way as we walk. Okay? But the answer is they're walking funny because the technology of that time wasn't able to open and close the shutter at the right pace. Okay? So it didn't look exactly the way we think it should look. Okay? But again, people walk the same way as they walk nowadays. The only thing is, our technology wasn't advanced enough so that we can open and close that shutter to get continuous looking things. Nowadays, you go to a movie theater, you see things looking very, very smoothly, and you don't see that choppy feeling. You don't have that choppy feeling. But again, that choppy feeling, the choppy feeling is not an illusion. The continuous feeling is an illusion. The fact that people are doing things continuously, that's just farce. That's not really true. Okay. So, those are Zeno's three paradoxes. And again, they go away if you think of space and time as somewhat discrete. I don't know if it's discrete or not, but that would deal with the question. Okay? But these are questions that have been around for 2,500 years, and the truth is there's no good answer to them. If there was, we wouldn't be talking about them. If somebody 1,000 years ago had figured out the real answer to Zeno's paradox, we wouldn't be talking about it now because we'd figure it out already. Okay. In the book there's another paradox called the stadium, but we're not going to go there and we're not responsible for it. Okay, speaking of the nature of space and time, let's talk about something called time travel paradoxes. So most movies, science fiction movies, are either about computers taking over the world and being evil about it, or time travel. And then you have some movies like Terminator where you have both. Okay, computers taking over the world and time travel. Okay, let's go through some movies that have time travel. Back to the Future, 1, 2, and 3. Terminator, Hot Tub. There's a great movie called Predestination. Looper, that's a good movie. There's a movie called Deja Vu, which is an excellent movie worthy of seeing. One of the Avenger movie, the X-Men movie has something Future Past or something like that. Okay, there's a hell of a lot of movies with time travel. And they're all very good. Okay, now, first of all, before we even start, I'd like to tell you why time travel just totally doesn't make sense. The whole concept of time travel, whether it's possible or not, we'll talk about that later, but just the concept of time travel doesn't make sense. Let me explain to you why. Okay, you ready? Let's say you want to go to 1776 in Philadelphia to watch the signing of the Declaration of Independence. Okay? Now, you get into your time travel machine. Stop. Before you get into your time travel machine, ask yourself the following question. Were you at 1776 witnessing the signing of the Declaration of Independence? Okay? And the answer is no, you were not. Okay? The very fact that you're watching this video means you were not there. You were not alive 240 years ago. Okay? 235 years ago. You were not alive 235 years ago, so you did not witness the signing of the Declaration of Independence. Okay? Not only that, but the signing of the Declaration of Independence was done in the summer in Philadelphia, and the people who were running things, they had a list of people. There's a list of people exactly who was in there and who wasn't in there. And not only that, but they wanted to keep the press out of it because there was a lot of bargaining going on. And so what they did was they closed the windows so that people wouldn't be able to see it. Okay? It was a closed meeting so that not everybody would be able to see it because there was a lot of rough and tough arguing and bargaining in order to do that. Okay, but there were minute takers, and we know who the minute takers were. There were secretaries. They were following things, so we know exactly who was in there. Guess what? You are not in there. Okay, great. Now, let's say you go back in time and you want to see the Declaration of Independence, the signing of the Declaration of Independence. Well, guess what? You did not see it because you were not in the room to see it. Okay? Now, if you go back and you transport yourself into that room, well, that's not the place which was the signing of the Declaration of Independence, because by definition, you were not there. So by you going back there, you are going to a place where you were. And that's not the past. You're changing the past. Okay? You're going someplace else where you were. Okay? But you weren't there now. Okay? Now, usually people start talking about different timelines. I don't know what that means. As far as I know, there's only one universe with only one timeline. But, okay. Well, some people, I've taught this before in class, and some people say, no, you go back as a ghost. I don't know what a ghost is. I don't know if you were there as a ghost or you're not there as a ghost. One student once told me, no, you go back as a fly in the wall. Okay. That's an interesting thing. In other words, you could say that there was a fly on the wall there, and you go back and you live in his body. Okay, anyways, those are different possible answers to say that time travel is possible. But let's just go through this again. Time travel is impossible, not impossible. It logically doesn't make sense because with the very fact that you're going back to someplace where beforehand you weren't, well, then you're not going back to where you want to go. You want to go to a place where you weren't before. So how do you do that? Okay, so that's a logical reason why time travel is totally, totally impossible. Okay, but besides that, I'd like to share with you other reasons why it's physically not possible. Okay, and these are called the time travel paradoxes, and one of the most famous is called the grandfather paradox. The grandfather paradox. And the idea is as follows. Go back in time and meet your bachelor grandfather. Your grandfather before he became a father. Okay? Before he got married. Before he was a father. Meet him and shoot him. Kill him. Okay? Now, what happens? Well, if you kill your bachelor grandfather, then you won't exist, because your father won't exist, because you killed him before he got married, and you won't exist. Okay? And the problem is, if you don't exist, you can't go back in time and kill your bachelor grandfather. Okay? So, if you don't exist, then no one's going to kill your bachelor grandfather, and if no one kills your bachelor grandfather, then your bachelor grandfather is going to live, get married, have a child, have a grandchild, and then you will live. So if you don't live, you will live. If you do live, you don't live. If you don't live, you live. If you do live, you don't live. Okay? That contradiction. Okay. Now, what's going on here? What's going on is our same old, good old-fashioned self-referential paradox. Okay? Here's an event. I'm going to let go of the eraser falls. I let go of the eraser falls. I let go of the eraser falls. I put down the eraser is there. Okay? In that case, one event is affecting another event. Let go of the eraser falls. Okay? I write on the board, there's writing on the board. Okay? One event affects another event. Okay? And that's very typical. But what's going on here is something a lot more interesting with the grandfather paradox. If you go back in time and you shoot your bachelor grandfather, what event are you affecting? Well, if you shoot your bachelor grandfather, your father won't be born, you won't be born. If you're not born, you can't go back in time, and you can't shoot your bachelor grandfather. So if the event of shooting your bachelor grandfather affects itself. Again, usually events affect other events, but here the event affects itself. And so if you shoot your bachelor grandfather, you cannot go back in time and shoot your bachelor grandfather. Okay? An event affecting itself. Let's remember sometimes we had that. We had the barber cutting his own hair. We had the verb, the noun, the verb modifying, talking about other words talking about other words. We had the reference book paradox. We had sets, which is books describing books. We have sets containing sets. And now we have events affecting themselves. Okay, great. So that explains what the grandfather paradox is. Now, the grandfather paradox happens in the world, the physical universe, and since we cannot have any contradictions in the physical universe, you cannot go back in time and shoot your bachelor grandfather. Just impossible. Okay, great. So that's the grandfather paradox, and it's a very interesting paradox. Okay. By the way, there are other versions which are less violent than the grandfather paradox. In Back to the Future, what happens? He goes back in time. And he makes sure that his parents don't meet, or parents don't fall in love. If his parents don't fall in love, then he falls out of existence. So they're playing with that theme also. Okay? So don't go back in time and make sure your parents don't meet. You have to make sure your parents do meet and they have you. Okay? So that's an example of the bachelor paradox, but without the violence. You don't have to kill anybody. But here's an even easier version of the self-referential paradoxes. Let's say you have a time machine. You open the door to the time machine. You go into the time machine. You close the door, and you press the button, and you go back 2 minutes or 1 minute. Okay? You press the buttons, and you go back in time, not to your grandfather, not to your parents' meeting, but you press back 1 minute. Okay? Now, you walk out of the time travel. Who's there? Your previous self. You were there a minute ago. Okay? So now there's you now and your previous self. Now watch what you do. Walk out of the time machine and push your previous self so that he doesn't go into the time machine. If your previous self doesn't go into the time machine, what happens to you? Well, then you didn't go into the time machine, and you can't go back 1 minute to push yourself away. So by pushing yourself, your previous self away, you're ensuring that you will not be able to push your previous self away. An event affecting itself. Let's go through that again. You walk into the time machine, you press the buttons, you go back 1 minute, you see an earlier version from yourself, you push that earlier version away, and by pushing that earlier version away, that means you cannot go into the time machine and push your earlier version away. Okay, so that's the world's simplest example of a self-referential paradox. Okay, I want to talk about a few other paradoxes that happen if you accept time travel. Okay. One is called the Bootstrap Paradox. This is not in the book, actually, but it's also called the Einstein Paradox for some odd reason. I'll explain to you why in a second. Okay, it goes as follows. In 1905, a young guy named Albert Einstein invented relativity theory. Okay, now, relativity theory, since it came out in 1905, 1915, a second version came out, it's been accepted as a given, and it's part of science. Great. Now, let's say you learn relativity theory. Okay? And you go back in time to 1903, and you meet this guy named Albert Einstein. He was a student or whatever. He was working in the patent office in Switzerland. He was a student. You go back in time, you meet him at a bar, and you sit down and you chat with him. And you take out a piece of paper and you explain to him the theory of relativity. Before he formulated it, you explain it to him. Okay, great. Question. Who formulated the theory of relativity? By the way, Einstein in 1903 learns it. He says, hey, this is a great idea. He decides, he doesn't know who this guy in the bar was, so he's going to write it in his own name, etc., etc. Who formulated the theory of relativity? Did Einstein formulate it? No, because I taught it to him. I went back in time to 1903, before 1905, and I taught it to him. Okay? Did I formulate it? No, I got it from Einstein. So where did the idea, did Einstein formulate it? No, he got it from me. Did I get it? No, I got it from him, etc., etc. Question, where did the idea of the theory of relativity come from? Okay, didn't come from me because I got it from Einstein. Didn't come from Einstein, Einstein got it from me. So where did it come from? altogether. Okay, so that's called the Bootstrap Paradox. It's a very strange thing. In other words, ideas have to come from somewhere. Where did this one come from? Okay, let me give you another paradox, but this is actually an interesting thing. But beforehand, I have a recommendation for you. Okay, YouTube recommendation. There's a twilight zone, a modern twilight zone. Okay, twilight zones are a science fiction show, and they have little snippets of movies. And one of them, you can look it up. It's for free. Okay, it's for free. It's on YouTube. It's 23 minutes. It's a fascinating video. It's called Cradle of Darkness. And what it's about is, at some point they get a time machine and they send back this actress, this woman, to go back to Austria in the 1880s when little baby Hitler is in a cradle. And they tell her, go kill baby Hitler. Okay? I don't want to give away the show. It's a very interesting show with an absolutely shocking surprise ending, but it's definitely worth watching. Okay, and they tell her, look, go back in time because Hitler, because of World War II, there were 40 million people killed. If you kill baby Hitler, then it won't happen. And so she goes back in time and she has to struggle with this, killing a little baby, but obviously her baby Hitler's parents don't want him to be killed. There's a whole little drama there, and it's well worth watching. It's called Cradle of Darkness. Okay, but this brings to mind another paradox. It's called the Hitler Paradox. It goes as follows. You ready? You go back in time. Hitler lived. You go back in time, and you kill baby Hitler. Okay? You change the future. Right? There's no World War II now. Okay, obviously people will argue with this. There's no World War II, there's no 40 million people getting killed, etc., etc. The world is a better place. And the world develops perfectly well. And there is a time travel machine. Okay? Now, let's say in 2021 there's a time travel machine and you go back to 1886 and you kill baby Hitler. Okay? That's very good. I would like to do that. Okay? I personally would like to do that and go back and kill baby Hitler. That would be a very nice thing for me to do. Okay? Because I know what Hitler did and I know all the bad things that he did, and so I would like to do it. But let's say I'm successful at it. Okay? Then there's no, baby Hitler dies as a 6-month-old baby. Okay, there's no Hitler in memory. There's nobody writing history books about Hitler. Okay, if he dies at 6 months, no one's writing books about him. There's no World War II. There's no after effects. There's no before, etc., etc. Okay, comes 2021. Okay, we have a time travel machine. Okay, now, should somebody go back and kill baby Hitler? Nobody knows who baby Hitler is. Nobody knows who baby Hitler is. Why should you go back in time and kill some little infant in Austria? What for? Okay? Again, now that Hitler lived, we know a reason why we should go back and kill him. But if we are successful at killing him, why should you send somebody back and kill him? Okay? So again, what's going is the event of killing Hitler is killing the motivation to kill Hitler. You're destroying the motivation to kill Hitler. Now, there could be, what you should do is, before you go back, you should write a note saying, look, I'm going now back in time. I'm going to change the past. Okay? You're not going to understand this, but by changing the past, I'm saving 40 million people. Now, when you hit this date, hello, future self, when you hit this date, Go back in time, go to the village of Linz in Austria, and kill a little baby named Hitler, Adolf Hitler. Just make sure you do that. Okay? Now, if you read this note, and you never heard of Hitler, and you never heard of World War II, you'd laugh, and you wouldn't do it. Okay? But let's go through what's going on again. What's going on is you're going back in time to when Hitler lived, and you're killing Hitler, and by killing Hitler, baby Hitler, you are ensuring that there's no motivation to kill baby Hitler. And that's a little bit of a paradox. It's not really a paradox, it's just, okay, there's no motivation. Okay. One more thing. Einstein, he formulated this relativity theory, and he had a way of looking at the universe, okay? And in that universe, time travel is not possible. There's no way you can go back in time. Okay? Einstein had a friend named Gödel, Kurt Gödel. You'll see his name over and over in this book later on. Okay? And Einstein was about 20 years older, but Gödel lived in Princeton. He was a university professor, and if you go to Google, you type in Einstein and Gödel, there's nice pictures of them. They used to walk down the streets of Princeton. In fact, Einstein used to say that the only reason why he goes to Princeton is so that he can walk Gödel home. Gödel was a super genius beyond compare. Okay? And Gödel was a logician. He studied logic, but Einstein used to talk to him, and Einstein explained to him the theory of relativity, and they used to talk about the theory of relativity. Gödel was a super genius. Okay, Einstein considered him more intelligent, and that's why Einstein would want to work with him. Okay, and Gödel wrote a paper in which he took Einstein's equations and he formulated a type of universe where time travel is possible. Okay, he looked at the universe. Einstein looked at the universe. It doesn't matter. In one way, Gödel looked at the universe in another way, and in Gödel's universe, time travel's possible. Okay. Now somebody, years later, in the 1970s, long after Einstein died, somebody went and interviewed Gödel. And they said to Gödel, this is printed, they said, Gödel, in your universe, time travel's paradox is possible. But you're a logician. You know about logic. You know that logic doesn't allow things to both exist and not exist. You're going to have time travel paradoxes if you permit time travel. In your universe, you're going to have the grandfather paradox. You're going to have things that cannot exist. So how do you deal with that? And Gödel said, no, time travel is possible. You can go back in time and shoot. You can go back in time. What is not possible is you're not allowed to do things that would cause a contradiction. So you can't go back in time and shoot your bachelor grandfather because that would cause a contradiction. But you could go back in time and, let's say, observe the signing of the Declaration of Independence. You can go back in time 1 minute and schmooze with your previous self. That you can do. There's no problem with that. You cannot go back in time and push your previous self and not allow him to get into the time machine. That would cause a contradiction. You can go back in time and bring your parents a wedding present. You cannot go back in time and stop your parents from getting married. Okay? Because that would cause a contradiction. So Gödel said, yes, you can go back in time, you just can't cause a contradiction in this world. Okay, great. That makes sense. But that brings in a lot more other questions. Let's say you go back in time and you decide you want to go kill your bachelor grandfather. So you bring a gun along. You shoot your bachelor grandfather. Will the gun not work? And the answer is the universe will make sure that the gun will not work because the universe is not going to let you do a contradiction. The universe is not going to let you make a contradiction. So either the gun won't work or the gun will work and the bullet will stop right over here, or you'll miss your bachelor grandfather, or you won't have the free will to kill your bachelor grandfather. But somehow the universe is going to make sure that you do not kill your bachelor grandfather. Okay, that just makes things a lot more interesting. Okay. Okay, we're now up to section 4, chapter 3, section 4. Okay, and these are little thought experiments, and they have to do with thought. Okay, so the first example we had of a self-referential paradox, we said, was this sentence is false. That's an English sentence that if it's true, it's false. If it's false, it's true. Okay, well, now we have the thought version of that. The thought version of that goes as follows. You ready? Close your eyes and think of the following sentence. This sentence is false. I'm sorry. This thought is false. Okay? If the thought is true, then the thought is false. If the thought is false, then the thought is true. Okay? So that's not about language, that's about state of mind. Okay? That's an interesting thing. Okay? Let me give you another one. Ready? Teacher comes in one day and he says, next week, teacher comes in Friday, and he says, this is a high school class where you meet Monday, Tuesday, Wednesday, Thursday, Friday. Teacher says, next week there's going to be a surprise test. Okay? Now, the purpose of the teacher saying that is so that you study over the weekend and you prepare for the test. But let's just go through this. Teacher tells you next week you're going to have a surprise test. Now let's say you don't have the test on Monday, you don't have the test on Tuesday, you don't have the test on Wednesday, you don't have the test on Thursday. Thursday night, what do you know? Okay, you know that the test is going to be on Friday, which means the test is not a surprise test. The test is not a surprise test because you already know Thursday night that the test is going to be on Friday. Okay, so, but the teacher told you you're going to have a surprise test. Conclusion, the test cannot be on Friday. There's no way in the world you can have that test on Friday, because if you have that test on Friday, it's not a surprise test. Make sense? So, again, if the test didn't happen Monday, didn't happen Tuesday, didn't happen Wednesday, didn't happen Thursday, then Thursday night you would know that the test was happening on Friday and it wouldn't be a surprise test. Conclusion, when your teacher says you're going to have a surprise test next week, he doesn't mean Friday, because then it won't be a surprise test. He means the test will either be Monday, Tuesday, Wednesday, or Thursday. Sounds good. Okay, so your teacher tells you next week you're going to have a surprise test. You know it can't be Friday, so it could be Monday. If it's not Monday, it could be Tuesday. If it's not Tuesday, it could be Wednesday. If it's not Wednesday, you know it can't be Friday. So Wednesday night, you already know that it's Thursday. Okay? So since it cannot be on Friday, Wednesday night, you know it has to be on Thursday. Okay, but that's a problem, because he said it's going to be a surprise test. So what do we prove? It can't be on Thursday. So the test is either on Monday, Tuesday, or Wednesday. Great. Teacher tells you it's a surprise test. We logically prove that it's either Monday, Tuesday, or Wednesday. Great. Let's say next week it didn't happen Monday, it didn't happen Tuesday. Tuesday night, you know it's going to happen Wednesday. But he said it's a surprise test. It can't be Wednesday. It can't be Tuesday, and it can't be Monday. Okay? So the whole thing can't happen. It can't happen. You can continue the same idea, and you realize it can't be any day of the week because, let's go through this. If you prove that it can't be Tuesday, Wednesday, Thursday, or Friday, then the only day it could be is on Monday. So then Sunday night, you know it's a surprise test. Okay? So it can't be like that. Now, the problem here is if the teacher tells you it's going to be a surprise test. By telling you that, that's causing the problem. Let's say the teacher doesn't tell you anything, and just one day, on a Tuesday afternoon, he says, I'm giving you a surprise test now. Okay, That defeats the purpose of a surprise test. The only reason why somebody would give a surprise test is to tell you beforehand, I'm going to give you a surprise test, and that way you're supposed to study way earlier. Okay? But let's say the teacher just gives a surprise test, doesn't tell you. Well, then there's no logical problem with it, because he never told you there's going to be a surprise test. He just, Wednesday morning, you come into class, he hands out a sheet and says, this is a surprise test. Okay? So the paradox comes about by you knowing that there's going to be a surprise test. If you didn't know there was going to be a surprise test, you wouldn't have the paradox. That's a very interesting thing. It's your state of mind that's the problem. Okay, I wanted to tell you something else about these paradoxes. Okay, there's a nice picture on the bottom of page 61. When you play a game with somebody, okay, let's say you're playing chess and you're strategizing. So you have the man playing against the woman. What is the man thinking of? He's thinking of, if I move this piece over here, what move are they going to make? Okay? I want to make the best move, keeping in mind what they're going to do. Now, what is the opponent thinking? Well, they're thinking, I have to keep in mind what I'm thinking. Okay, the opponent has to keep in mind what I'm thinking. And what am I thinking? I'm thinking of what the opponent's thinking. And so you have this nice picture of people thinking about other people, thinking about themselves, thinking about other people, thinking about themselves, and you get into some type of paradox using that type of thought. Okay? But again, it comes from states of mind. Okay? Okay. Okay. One more paradox. It's a little bit longer, but one more paradox. It's an interesting paradox. It's called the Monty Hall Paradox. Okay? And there's a long story that goes with it. Okay, so there used to be a television show called Let's Make a Deal. And the host of the show was Monty Hall. And Monty Hall used to go over to people and make them different deals and offer them money and offer them different things if they do this or they know this, etc., etc. So imagine for a second that Monty Hall presents to you 3 doors. And he tells you behind 2 of the doors is a donkey. Behind 2 of the doors, each one of them has a donkey, and you don't want a donkey. But behind the 3rd door, there's a brand new car. Okay? You want a brand new car. Okay? Everybody wants a brand new car. Okay? And Monty Hall says to you, all you have to do is pick out which door you want, and you're going to get whatever's behind that door. If it's a donkey, you get a donkey. If it's a car, you get a car. Okay? Now, obviously, you want to pick out the door with the car. Great. Now, let's say you choose this door, just for the hell of it. Okay? And you're about to open the door to see if you got the car or the donkey. But before you go, Monty Hall goes over to you and says, hello, let me open this door for you. And behind this door, you see a donkey. Okay? So again, Monty offers you 3 doors. You choose this door, and before you open this door, he opens this door. Okay? And now Monty asks you the following question. You can have this door that you want, you can stay with this door, or if you want, you can swap to this door. Which would you like? Okay? Do you want to stay with this door, or do you want to swap to this door? Now, most people would say, what's the difference? It's a 50-50 chance. It's either, I know the car is not here, so either this has the car and this has the donkey, or this has the car and this has the donkey. What's the difference? Why swap? Okay, most people would say that. Okay. Now, what happened was there was a magazine called Puzzle Magazine, and there was a woman who wrote a column in this. Her name was Marion Vassavant. Okay, she's recorded with the highest IQ. She deals with puzzles all days, and so she knows how to answer these questions, and she has the world's highest IQ or something like that. She has a very high IQ. And somebody asked her this question: should you swap or should you stay the same? Okay? And Miss Savant, or she's a married woman, whatever, and Marion Vassavant said, you should definitely switch. Okay? You should definitely switch. Okay. Supposedly, 10,000 people wrote in letters to her telling her she's absolutely wrong. There's no reason why you should switch. You should stay the same. Okay? And this went on for months. People were arguing it. Supposedly, of the 10,000 people, 1,000 people wrote in that they have PhDs in math or statistics, and they said, doesn't make sense. You could stay the same. Your probability of winning will not help you. Okay. Turned out she was 100% right. You should switch. Okay? And this caused a whole uproar, and it hit the front page of the New York Times. On a Sunday morning, there was 20, 30 years ago, there was a front page article about this paradox that was getting people very upset, etc., etc. Now, in the book, I explained to you why you should switch. Okay? Let's say the car is here, and the other two have donkeys. Okay? And you're going to choose one of three things. You're either going to choose this, this, or this. Okay, so if you choose this, Monty's going to open this, okay, and the car is there, and you lost. If you choose this, Monty's not going to open the one with the car, he's going to open this one, and you stayed, he's going to choose this. You're going to lose. If you choose this one, Monty's going to either open this one or this one, and you're going to stay with it, you're going to win. Okay? As opposed to that, if you switch every time, you automatically win. Okay, and not automatically win. You win 2 out of 3 times. Okay, you look in the book; it's very clearly stated. Okay. Question: why should you switch? Okay. Now, usually I do this with cards in a classroom, and what I do is I show you the experiment in the book. Let's say I have 25, I don't have 3 boxes, I have 25 boxes. So I'm not going to do it all, but let's say you have 25 different doors. Let's do it quickly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And Monty says, choose one of these things. And let's say you choose this one. Okay, great. You choose that door. Now, the chances of you being right now is 1 in 25. Again, assume there's 1 car and 24 donkeys. Okay? The chances of the car being behind here is 1 in 25. Great. Now, let's say Monty decides to open the door. He opens this door, and he shows you a donkey. D for donkey. Okay? Should you switch? Probably not. Where should you switch? Okay? Well, let's say he goes on. He opens this one. He opens this one. He shows you this has a donkey. He opens this one. 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 He opens this one. He opens this one. He's not going to open this one. You just chose that one. He opens this 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 one. He does not open this one. He opens this one. He opens this one. He opens this one. Okay? And now he asks you, he skips this one. And now he asks you, do you want to switch? Okay? Now there's two possibilities here. There's two possibilities. One possibility is you actually chose the right one. Okay? Right there, behind this one that you chose is the car. But Mr. Monty Hall is trying to trick you. He doesn't want to lose the car to you. So he stopped and he opened all the doors except this one. He wants you to switch from here to here, okay? And really behind here is a donkey. He doesn't mind giving you the donkey. He minds giving you the brand new Lexus. He doesn't want to give you the Lexus. Okay? That's one possibility. Okay? The chances of that being true is 1 in 25. Because you chose this. Chances of the car being there is 1 in 25. As opposed to that, what's another possibility? The other possibility is, you ready? You chose here. Behind here is a donkey. Mr. Monty Hall opened all the doors except this one. Why didn't he open this one? Okay? Because this one has the car. That's the other possibility. So, question, should you switch or should you not switch? I think most people now would say, you better switch. Again, the chances of you winning beforehand is 1 in 25. The chances of this being the one that he didn't open up is not because he's bluffing, but because really this has the car. That's 24 out of 25. Your odds are better to switch than to stay the same. Okay, what's going on here? What's going on is as follows. By Monty Hall skipping this one, or let me put it the other way, let's talk about the original experiment. You have 3 doors. Okay, you chose one. By Monty Hall opening this door, look what he's doing. He's not going to open this door, he's going to open this door. There's a donkey over there. He avoided this door. The very act of him avoiding this door is telling you something. It's an amazing thing. Okay? By not telling you what's behind that door, he's telling you something. And that's an amazing thing. Okay? So, you should switch here. You should also switch here. Because he avoided this door. Now, he could be avoiding this door just to bluff you. But that's a 1 in 3 chance. Okay? Okay? There's a 2/3 chance that you're going to win if you swap. Okay, that's a very nice thing. One last little idea about the Monty Hall thing. Ready? Let's say you look at Monty Hall and you see that Monty Hall is drunk. Monty Hall doesn't know what he's doing. Okay? Monty Hall does not know what he's doing. He doesn't remember. He drank too much that morning and he doesn't know what's going on. Okay, you can see he's stumbling, he's mumbling over his words, he doesn't really know what's going on. Okay, so Monty Hall says to you, you can choose one of 3 doors. Behind one door is the car, behind 2 doors is the donkey. Okay, and you choose one of the doors. Let's say you choose this one. Now Monty Hall is stumbling. He walks towards the door. He says, before you open that door, let me open this door and show you what's behind there. Now, Monty Hall doesn't, let's say Monty Hall doesn't really know where the car is. Okay? And he accidentally opens the door from the car. Okay? Well, game's over. You want the car. You don't want the donkey. So it doesn't matter if you switch it. You don't switch. That game is over. Okay? It's just not interesting because he showed you already where the car is and he's not going to let you switch into that one. Okay? So you're choosing between this donkey or that donkey. That doesn't interest you. Okay? But let's say Monty Hall walks towards the 3 doors. He has no idea where the car is and he opens up another one and there's a donkey there. Now if he did that, and again he opens this up and there's a donkey here, but he didn't know if the car is here or the car is here. He didn't know if the car is here. Because he's drunk, he doesn't know if the car is here or the car is here. Then it really doesn't pay to move. Why? Because it's not he was avoiding this because he knows the car is there. He just randomly chooses one of them. Okay? By randomly choosing one of them, he happened to open one with the thing, but it could be that the car is here or the car is there. You don't know. Okay? So, what I said was, Monty Hall gives you information by not giving you information. But if Monty Hall is drunk, then he doesn't give you information. So again, it's the state of mind that causes it. Okay, that's the end of chapter 3. I strongly urge you to read the whole chapter. It's really, really interesting stuff. Okay, we are finished.